Electric power consumption will be hardly reduced in the future. The more electrical devices, the more electricity required. Indeed, the price we have to pay for our comfort gets higher. However, some innovations are aiding to save non-renewable resources to some extent. This video features the smartest and the most original ones. PaveGen. People get more dependent on fossil fuels to produce electric power year by year. Resources don't add up while the power consumption keeps increasing. The problem was of great interest to Lawrence Kemble Cook as early as in 2009 when he was a student of Loughborough University. In 10 years, he managed to create the PaveGen company. It manufactures sidewalk tiles that can convert pedestrians' energy into electrical power when they are walking on it. The tiles are made from recycled abrasion-resistant automobile tires. When stepped, the tile surface suppresses by 0.2 inches, inducing the inbuilt transducer to generate electrical power. The energy can be used for sidewalk lights or accumulated in lithium batteries. The company's technology of this power generation is still kept a secret. Icewind Iceland. City lights, municipal transport shops, pedestrian underpasses, sidewalks, and other urban landscape objects require lots of electric power. Besides, controlling their power consumption is rather difficult. The Icelandic company Icewind developed an extraordinary solution to provide electricity for urban objects using wind energy. The system can work efficiently only when the wind speed exceeds 7 meters per second. However, it is equipped with a braking system that prevents the turbine from rotating faster than 2 meters per second for safety reasons. Turbines are made from very lightweight and durable carbon fiber. The maximum power capacity of such generators ranges between 100 and 1,000 watts, depending on the model type. Kite power systems. Using wind energy to generate electric power is not new. Nevertheless, it is relevant for North European countries and Switzerland in particular where strong winds are common. Most air currents form at the Alpine foothills and have not been employed in full so far. Besides, controlling the wind in Switzerland is a dubious venture doomed to no success. Winds can change their direction every minute over the lakes and Alpine foothills. The Swiss company Kite Power Systems did manage to conquer the power of wind though. The first wind turbine was installed at the Alpine St. Bernard Pass. It was 295 feet in diameter, and the apparatus was 502 feet high. Its developers state that Kite Power Systems can operate in any area with wind speed exceeding 6 meters per second, and one device performance can sufficiently support the electric power needs of 86,000 households. PaveGen Tidal Power Project. Generating electric power from the energy of tides is way more difficult than the energy of wind. However, it never stopped the company PaveGen Tidal to construct a mighty power station with a capacity of 398 megawatts on the shelf between the ultimate north coast of Scotland and the small island of Stroma. Being only 11,154 feet wide, the site flaunts water energy enough to generate 86 megawatts of electric power. Developers proved that tidal power can be as productive as wind or solar energy. Each turbine stands on a base weighing between 260 and 350 tons. At the same time, the ballast mass reaches 1,200 tons depending on the place where the turbine is installed. As a result, the system performance went beyond all expectations. The power is used by at least 2,600 households. Vortex Bladeless. Any wind generator is potentially dangerous. The machine kinetic power is almost impossible to control. That is why such power stations are typically mounted in remote places. This problem was addressed by the Spanish company Vortex Bladeless. Such wind generators turned to be more efficient than traditional blade ones and required less time and money to install. Furthermore, the system does not actually entail large rotating elements. The working principle of bladeless generators is way more difficult, but its efficiency could never be denied. Vortex flows blow at a vertical generator, thus moving the power generating axis. Obviously, designers do not disclose technical details. However, a single 492-foot-high generator of this type can produce up to 1 megawatt of electricity. Carbon engineering. Many specialists regard the global warming problem as artificial. Nevertheless, we should not ignore the increased concentration of gas carbon in the atmosphere. Also, we can productively use carbon dioxide and significantly save on that. To be more precise, scientists estimate the price for 1 ton of carbon extracted from the air. It is around $100. The unique Canadian project, Carbon Engineering, targets not even making a profit on carbon, but to a greater degree, cleaning the atmosphere and reducing the civilization's impact on the global climate. The idea embraces the possibility to get carbon from the air. After the air is taken from the atmosphere, it is concentrated in the carbonate solution. Then decarbonization takes place, splitting the solution to pure gas carbon and ordinary lime. Smart Flower Solar. Manufacturers of solar systems generating electric power state that the minimum area to supply electricity for the needs of one household should be at least 22 square yards. This is a significant fact to consider. Using the system Smart Flower Solar, we can forget about the total area of power generating surface. Here are the major reasons for that. First, the system tracks the sun's position. Second, it employs unique panels. These factors make Smart Flower Solar 40% more efficient than its competitors. 12 petals follow the sun from the early morning till twilight and clean off the dust on their own at the end of the day. On top of that, the system supports optimum temperature not exceeding 7.8 degrees. Cape Sharp Tidal. Windy and full water regions can always rely on alternative sources of power. However, this does not refer to territories where the climate is calm. For example, Newfoundland and Labrador are subject to climate changes as well as to soil erosion, making most methods of generating the alternative electricity not available here. Nevertheless, those areas witness stormy winds, but on the perfectly tranquil sea surface. Similar situation is common for Singapore, China, and Taiwan. No wonder that this question got the interest of Canada, washed by oceans from 3 sides. It was calculated that the average power capacity of a Canadian wave makes 37,000 megawatts per hour. Converted to electrical power, the energy of water will support the electricity needs of 55% of the Canadian population. This is the aim of the government project Cape Sharp Tidal, that has been fruitfully operating for already several years, bringing decent results. For example, it is planned to increase the capacity of the Cape Sharp Tidal system up to 300 megawatts, which is enough to supply 75,000 customers.